45. So my slope is going to be around 45. If you had a slope of like, I don't know, like 40 or 50, you're not way off. But if your slope is, 10, you're going to be pretty far off on that. So you're going to want to revisit that. So if you look at your slope is 45, now I'm going to write my function, write the linear function to model this. I'm going to write f of x equals. Now, if I had a y-intercept right along here that I could see, I would put it in slope-intercept form. But since I don't, I'm going to use point-slope form. We talked about this the other day as well. And I'm going to put the 45 as my slope, parentheses, and then x. And then I can use any coordinate here that I want to. I'm going to use the 490. So I'm going to use x minus 4 and then plus 90. And I can put that in my calculator and I can look to see how close these values are to it. Again, you're going to see they're going to be off a little bit. And then it talks about how is this data correlated. And this, if you look at it, it's got a positive slope. Right? It's not close to 0. It's going to be a positive correlation. And then use the model, the linear model, the data to estimate the number of cottonwoods planted in 2006. Right? So now we're actually going to use this to make an estimate. And if we look at this in 2006, years since 1995, 2006 is going to be 11 years since 1995. So what we're going to do now is we're going to say f of 11 equals 45 times 11 minus 4 plus 90. And I can just put this in my calculator and get the value for this, or I could have put this function into my calculator with the x and then gone to the table to where x is 11. Alright, so let me do that calculation real quick. That is going to be 45 times 11 minus 4 and then plus 90, and that gives me 405. So that's a good estimation for how many plants will be planted in 2006. Now explain how this data could be useful to a farmer, to a scientist, to a botanist, or to a homeowner. All right, if you're thinking about trees planted, right? If you are running a greenhouse, I'll write that down. A greenhouse, or you are making trees. Knowing how many trees are needed in Oregon in the year 2016 might be helpful if this trend were to continue, because then you know how many that you need to plant, that you need to start, so that people can take them and they can plant them. So that would be one way that it might be helpful. It also might be helpful if the cottonwood plant or the cottonwood tree is really involved in allergies, like I'm sure most cottonwood trees and hybrids are. So knowing that there'll be more and about how many they're going to be, and is that going to really increase the number of allergies that people have, and looking at that trend. So those are just a couple of ways that that this data could be useful. Right? So now your job is to go down to the one on the bottom and the one on the back and answer these same questions, drawing in your line of fit. You might want to check with the person next to you after you get your line of fit, after you get your function for it, and see that your slope is similar to theirs. Again, it doesn't have to be the same, but it should be similar, in the same ballpark. All right?